Hello guys, welcome back to Free Fall again. This is part 3, problems. We are going to go over a few problems to have more practice. You remember in part 2 I explained all the lesson, formulas, graphs, whatever. Please watch it and the link of that video is in the caption. And if you have watched it, let's continue. Number 1. A ball is released from a height of 20 meters. Released means initial velocity is 0 and then the ball comes down, falls down. And this is the striking point. Of course, at the point when the object touches the ground, normally the velocity must be maximum. It's exactly a moment before it touches the ground. Okay, and then total displacement will be negative 20 meters. Delta y is negative 20 meters. Why? Because the delta y is a vector connecting the beginning point and the end point. So as it is downward, it must be negative. So delta y is given. Finally, the time of the free fall is the goal. G is given to be 10 meter per second squared. Okay, what should we do? Here we should know which formula matches the best. So let's see what are the quantities given and what's the goal. The given quantities are G, we know that. V naught is given, 0. Delta y is something we know, negative 20. And we are looking for T. Okay, the best formula connecting these quantities is delta y equals negative a half of gt squared plus v naught t. It's the best because this is the goal, T. And we are looking for T. Okay, let's do it. For delta y, I plug in negative 20. You know why it's negative? Because it's downward. For g, I plug in the 10. Negative also is here. And v naught is 0, so no need to continue with the second term. I substitute the values, and here I forget about this negative sign. Then let's multiply 2 by 20. It will be 40 equals 10t squared. And then divide both sides by 10. I will get 4 equals t squared. And then I will have t to be 2 seconds when you take a square root. Okay, the total time of this journey of this free fall is 2 seconds. The next part of the problem is the velocity of the ball when it strikes the ground. Guys, you know that velocity must be negative because the object is coming down. And so finally at the point when it touches the ground, it's coming down. So velocity must be negative. Again, let's go over the given and the goal quantities. Here I have V naught, I have G, and also I know the T is 2 seconds, and I'm looking for V. The best formula matches with the given quantities here will be V equals negative GT plus V naught. Of course, as the V naught is 0, let's forget about it. And then let's continue. Negative G is negative 10 and time is 2 seconds. So the final velocity is negative 20 meters per second. Of course, you know that the speed is 20 because the speed cannot be negative. But as the velocity is the goal, it must be negative 20 meters per second. Number 2, a ball is thrown upwards with a velocity of 30 meters per second. Here, as you see, the object is thrown upward, then it goes to the maximum height, let's say it's peak point, and then goes back. You know that the critical points are beginning point A, peak point B, at which the velocity is 0, and then finally C, at which the velocity is negative 30 meters per second. You know that the velocity behaves as a symmetrical quantity. I mean, when the object, for instance, passes through this certain height for 9 meters per second, it goes back to the same height with the same speed but negative velocity, negative 9 meters per second. You know that. Okay, part A. When it reaches the maximum height, when means time. So I'm looking for time. The given quantities are V naught. It's exactly VA because VA is V naught here. It's 30 meters per second. It's 30. And then VB is the final velocity, which seems to be 0 because it's the peak point. Final velocity is 0. And G also is given to be 10. Then I'm looking for T. The best equation matching all these given quantities will be v equals negative gt plus v naught. I have everything here except t. So let's do it. I plug in 0 for the final velocity at the point B because I'm considering the motion again from A to B. V naught is going to be 30 and then G 10 and then T is easily found to be 3. Why? Because if you take the 30 to the left side, it will be negative 30 equals negative 10t. And if you divide both sides by the 10, you will get 3 equals t. Finished. The total time is 3 seconds from A to B. Part B. Find the maximum height. Maximum height means the distance between A and B. So let's say delta y from A to B. The given quantities again. I'm looking for delta y, and the given quantities are v naught here from A, 30, at B, the final velocity is 0. Also, I know that the total time for A to B is 3 seconds, t is given to be 3. So I think I can use delta y equals negative a half of gt squared plus v naught t. And I will plug in the values and find delta y from A to B. The other approach, which seems to be a little bit easier, is using the time-independent equation. The reason is that there is no t here. And if we have made any mistake in finding t, it won't affect the next part, the next solution. So I prefer to use this one. Final velocity is the velocity at point B. It will be 0. Initial velocity is 30, so it's raised to the power of 2. It will be 900. G is 10 here. Let's plug in the values. If you don't mind, let's call A to B to be h. It's the height, the maximum height. It's just another notation for delta y. Okay, negative 900 is here and negative 20 is here times h. Forget about the 0 here, so h will be negative 90 divided by negative 2, so it's 45. So finally I will find the total displacement from A to B, or the maximum height, h, to be 45 meters. Let's continue for the part C. When it goes back to its initial position, means the time from A to C. You know that according to the YT graph, this motion is has a symmetrical position time graph. Symmetrical because the beginning point A and the final point C are at the same height. So according to that symmetrical shape for this YT graph, the time from the A to the peak point, which is B here, is 3 seconds. Normally, when it goes back, it takes the same time, as the mathematical properties of the parabola implies the time from B to C will be the same. So the symmetry tells me that, again, I will have a 3 seconds here. So totally, the time from A to C must be 6 seconds. It does not need any more writing equations or some complicated solutions. It's very easy to do. And the last part is D. What is the displacement of the ball after 2 seconds? When they say displacement, explicitly they are telling you what is delta y. But delta t here is not the total time. It's not from A to B. It's exactly 2 seconds. What should I do for that? Let's consider again what are the given quantities. What is the goal? Goal is delta y. The given quantities are g, which is 10. I know that, the acceleration, free fall acceleration. Delta t is given to be 2 seconds. It's the same as t. And also I know that the initial velocity here is 30. Okay, let's find the solution of an equation which matches the best for the easiest approach. I think we can write again delta y equals negative a half of gt squared plus v naught t. You see that I have v naught here, I have t here, I have t here, and I know the g. So finally I will find delta y. It's very easy. Let's plug in the values. T must be 2 seconds. Here raised to the power of 2. Here is just 2. This term will be 60, and this term will be 20. Negative 20 plus 60 will be 40. So total displacement from A, F, and then after 2 seconds, let's say the point D. This is the point D after 2 seconds will be 40 meters. Necessarily, it's smaller than AB, which was 45 meters, because you know that from A to B, it takes 3 seconds. So if you say 2 seconds, it will be less than that. So the object is still going up. Suppose that the problem wants the velocity of the object after 2 seconds. It's very easy. The velocity will be v equals negative gt plus v naught. The velocity will be negative 10, t is 2 seconds, and v naught is 30. Is easily seen to be negative 20 plus 30, so it's positive 10 meters per second. 10 meters per second means that the object is still raising up 10 meters per second. And finally, it stops at B. That's all. Let's go to the next question. Question 3. Antonio stands at the edge of a vertical cliff and throws a stone vertically upwards. The stone leaves Antonio's hand with a speed 8 meters per second. Okay, so the initial velocity will be 8. The time between the stone leaving Antonio's hand and hitting the sea is 3 seconds. So the object goes up, gets the peak point, goes back again, and will touch the sea level totally for 3 seconds. Assume air resistance is negligible. This is the ideal condition for free fall. A g is given to be 10 meters per second squared. Part I, calculate the time taken by the stone to reach its maximum height. Let's say it's t1. I mean the time from point A to the point B. B is the peak point. Pay attention, velocity as at B, the peak point will be 0. So I know the initial velocity, I know the acceleration, I know the final velocity, and I'm looking for t. The best equation and the easiest approach for that, matching with the given and the wanted quantity, will be v equals negative gt plus v naught, and my goal is the t. So let's plug in the values. The velocity at the point B peak point will be 0, so it's 0, negative g is 10, 10t plus 8. Just I will take negative 10t to the left, so it will be 10t equals 8, and t will be 8 divided by 10, so it's 0.8 seconds. It's the time from A to B, from the beginning point to the peak point. Part II, the height of the cliff. Height of the cliff is h, capital H. Let's say it's capital H. I put a vertical axis like y here, and I take here to be y equals 0. You know that it's going to be the initial height. So the initial height is assumed to be h, capital H. We know that the total time also is 3. So I know the t, I know the acceleration, I know the initial velocity v naught, and I know the final position y, because y will be 0. When the object touches the sea level, y will be 0. But it starts from capital H. So I know that y naught is h, it's my goal, but final destination, final position for the object will be y equals 0. Also v naught is given, g is given, the acceleration, the total time also given. The best approach here will be y equals negative a half of gt squared plus v naught t plus y naught, because it's exactly my goal and all the other quantities are given here. I know everything. So let's plug in the values. Y is 0 when the object touches the sea level. Here 10 for the g. Total time is 3 seconds for the whole journey. Here also t is again 3, but initial velocity is substituted for 8, and it's my goal, h. So let's check the quantities. Here I have negative a half of 10 times 9 plus 24 plus h. Here it's going to be 45, negative 45 plus 24 plus h. It's equal to 0. Very good. So h will be 21. This is the answer for double I. Part triple I. The maximum height reached by the stone. Maximum height will be from the ground to the peak point. So first I should know the displacement from A to B here, and then I will add up the value by 21 to get the total height, H max. It's very important because in previous part in double I, we found that initial height is 21. So let's find A to B, the delta y from A to B, and then add up a 21 to find the total maximum height. Okay, here I think delta y negative a half of gt squared plus v naught t again is the best for A to B. Why? Because here the v naught is given to be 8, v will be 0, you know why, because it's getting the peak point, g also is given, and I know that the t from A to B, from the previous part, from the first part of course, is 0.8 seconds. So everything is here. I'm just looking for delta y from A to B. So let's plug in the values. G is 10, t is 0.8 raised to the power of 2 from A to B, v naught 8, and t again 0.8. Okay, here I have 0.64 multiplied by 10 multiplied by a half but negative plus 6.4. And then here it's 6.4 divided by 2 but negative plus 6.4. It's very good. So it's negative 3.2 plus 6.4. So it will be 3.2. That's all. 3.2 from A to B. And then I'm looking for the total maximum height. So H max will be 21 here plus 3.2. So finally I will get Y max to be 24.2 meters. Number 4. A student drops a stone from rest at top of a well. She hears the stone splash into the water at the bottom of the well 2.3 seconds after releasing the stone. The stone comes down, falls down here, and then makes a splash sound, and then the sound very quickly goes back to the initial position. You know that the sound is traveling really fast, and because of that, relative of course to the stone. Ignore the time taken for the sound to reach the student from the bottom of the well. This is why, as the sound is moving really fast, this is why we ignore that time, because the sound travel is really short compared to the time we need for the stone to fall down. G, again, given to be 10 meters per second squared. Okay, part A, calculate the depth of the well. Depth of the well will be delta y. Of course, we will find the magnitude of that. Normally, delta y is a negative value, but finally, I will take the absolute value. It's not very big deal. Initial velocity is given to be 0, I know, and I'm looking for the delta y. G is also given to be 10, and you remember that the total time for this journey is 2.3 seconds. So we know everything except delta y. Let's connect them with this equation again. Delta y is equal to negative a half of gt squared plus v naught t. We know everything except delta y. You see the right side, all the quantities are given. Let's plug in the values. Here g is 10 and the time is 2.3, but forget about the v naught as it starts from rest, so v naught is 0. The second term will be ignored. Okay, it's very easy. Just use a calculator here. It's negative a half of 10 times 2.3 times 2.3. And then finally, the delta y will be negative 26 meters, but pay attention, for the height, we will get the value to be 26, not negative 26, but anyway, the absolute value is the same. Part B, calculate the speed at which the stone hits the water surface. It's very important to notice that the velocity will be negative here and the speed will be positive. Whatever you find for the velocity, let's say the velocity is -8, whatever, it's not important for me. The speed will be 8. Be very careful about that. Okay, what are the given quantities and what's the goal? The given quantities are v naught equals 0 because it's released from rest, g is given, and I'm looking for the speed for the v. Okay, let's find a relation between an equation relating v naught, g, and also the t. T is 2.3 seconds. The best for this approach will be v equals v naught minus gt. You know that all the quantities are given on the right side of this equation, so I will find the v. Let's do it. V naught is 0, it's here, g is 10, and t is 2.3. Normally, it's going to be negative 2.3 meters per second. This is the velocity, but as it's looking for speed, let's say speed here will be 23 meters per second. Thank you for watching this video. Again, I emphasize, please have more practice. See you.